Good morning, students. Welcome to online learning. Today, 11th April, and we are delivering third lecture on relations and functions for class 12 mathematics. So, in last lecture, we have discussed regarding empty relation and universal relation. Today, we will start discussion from identity relation. So let us see identity relation. Identity relation. Identity relation. So regarding this identity relation, we will write R equals to A comma A for all A belongs to capital A. That is a given set, and there should be no any extra element, and there should be no any extra element. What we mean by this? R equals to A comma A for all. This is a symbol for all. This is the symbol for all. So for all A belongs to capital A. Okay. So R equals to A comma A for all A belongs to capital A, and there should be no any extra element. Suppose A equals to 1, 2, 3 this time. Okay. Now try to write identity relation on set A, where A belongs to capital A. So R equals to, what we will do? We will consider first entry 1, and we will try to write this type of relation A comma A. That means 1 comma 1. Next we will consider this entry 2, and we will write 2 comma 2. Okay, is it clear? Now see, next entry is 3. We will write 3 comma 3. Read this definition again. A comma A for all A belongs to capital A. So we have considered all entry of set A 1, 2 and 3, and for this we have 1 comma 1, 2 comma 2 and 3 comma 3. Now read this, and there should be no any extra element. So we should close it now. This is our identity relation. R equals to 1 comma 1, 2 comma 2, 3 comma 3. So now consider reflexive relation. Reflexive relation. So for reflexive relation, R equals to A comma A for all A belongs to capital A, and there may be any extra element or may not be, or may not be. What we mean by this? Reflexive relation, R equals to A comma A for all A belongs to capital A, and there may be any extra element or may not be. That means what? What is basic difference between identity relation and reflexive relation? Up to this point, both is same. A comma A for all A belongs to capital A. A comma A for all A belongs to capital A. But after this, in identity relation, there should be no any extra element. while in reflexive relation there may be any extra element or may not be. So just try to write reflexive relation. R equals to, we have to write A comma A. Consider capital A 1 2 3. On set A we are trying to write reflexive relation this time. So first element 1, try to write A comma A 1 comma 1. Okay, then again second element 2, try to write 2 comma 2, then 3 3 comma 3. Okay, now there may be any extra element or may not be. Suppose this time we are closing it here and we are again writing some another relation. Let it be R1. We are writing R2 1 1 2 2 3 3 and 1 2, and now we are closing it. Is it a reflexive relation? So read definition. There should be A comma A for all A belongs to capital A. Check it. We have A equals to 1 2 3, so there should be 1 1 2 2 and 3 3, and after this there may be any extra element or may not be. So may be or may not be. In R1 we are not having any extra element. In R2 we are having one extra element 1 comma 2. So in both the cases it is reflexive relation. According to definition, there may be any extra element or may not be. Suppose I am writing one more relation R3 1 1 2 2 3 3 2 3 1 2. Is it a reflexive relation? So just we need to check that whether A comma A exists or not for all A belongs to A, and after that there may be any extra element or may not be. So again 1 1 2 2 3 3. We have some extra element here 2 3 1 2, no problem, because in definition it is given there may be any extra element, so it is a reflexive relation. One more relation I am writing here R4. Suppose I am writing here 1 1 2 2 1 2. Is it a reflexive relation? Is it a reflexive relation? How we will check? So at first we should check that whether A comma A exists or not for all A belongs to A. So 1 1 2 2 exists, but we are not having for 3 3 comma 3 is not here, so it is not a reflexive relation. Is this clear? So our primary check, there should be A comma A for all A belongs to capital A. If any entry is missing, we can say that this is not a reflexive relation. But if we have all entries and apart from this we have some more entries, no problem, it is reflexive relation. So now can you explain what is difference between identity relation and reflexive relation? So suppose we have to check R1, R2, R3, R4 for identity relation. How we will check? Is R1 identity relation? Yes, R1 is identity relation, because according to definition of identity relation there should be no any extra element. We are not having any extra element and all A comma A exist for all A belongs to capital A 1 1 2 2 3 3. So R1 is identity relation, but R2 is not identity relation, but it is reflexive. It is reflexive. R2 is not identity relation, but it is reflexive. But it is reflexive because we are having some extra entry here. There should be no any extra element to qualify for identity relation, but there may be extra element or may not be for reflexive relation. Is it clear? So R2 is not identity relation, but it is reflexive. Again you can say for R3, R3 is having entry 1 1 2 2 3 3, but apart from this we have 2 3 and 1 2. So R3 is not identity relation, but it is reflexive. So you can say here R2 as well as R3. For R2 and R3 you can say this definition is not identity relation, but it is reflexive. What is for R1? R1 is identity as well as reflexive. We can say yes, R1 is identity relation, R1 is reflexive relation. For R2 and R3 idea is clear. Now see for R4. Whether R4 is reflexive, we have already discussed. R4 is not reflexive. Now whether R4 is identity, obviously not, because two reasons we have here to decide that whether R4 is identity or not. One is 1 1 is available, 2 2 is available, but 3 3 is not available. So based on this reason we can say that R4 is not identity. Apart from this we have some extra entry here 1 2, so R4 is not identity relation. So we can say R4 is neither identity nor reflexive relation. R4 is neither identity nor reflexive relation. I hope idea about concept regarding identity relation and reflexive relation should be clear now. Okay, so let us see some more practice on reflexive relation. We have one chart here for reflexive relation. One side some relation is given, relation on set A, and let this time set A is 1 2 and 3. Based on this set we have to answer that whether relation on set A is reflexive or not. In this column we have to fill yes it is reflexive or no it is not reflexive. Idea is clear? Okay students, one thing I want to recall you that can you able to understand this thing, relation on A? Recall in first lecture we have discussed, in first or second lecture, कि relation on set A means relation on A cross A. At that time we have discussed Cartesian product on A cross B and Cartesian product on A. Okay, so the same thing is here, relation on A means relation on set A, and relation on set A means relation on set A cross A. Okay, so relation on A means relation on A cross A. What is A cross A? If A is 1 2 3, so A cross A means you have to write one more A here, 1 2 3, and A cross A means 1 1 1 2 1 3. So 1 1 1 2 1 3, then 2 1 2 2 2 3, and then 3 1 3 2 3 3. This is your A cross A. So basically relation on set A. What is relation? You can recall, relation is any subset of Cartesian product of two non-empty sets. So this time relation on set A is relation on A cross A. A cross A is this. So these are the subsets, you can say. Is it clear? So these are the subsets of A cross A, and any subset is a relation on set A. Fine. Now R equals to phi. Is phi a subset of A cross A? Of course yes, because we know that empty relation is empty set is subset of each set. So R equals to phi is a relation on set A. We have to decide that whether it is reflexive or not. Be careful. Read the statement relation on set A, and set A is 1 2 3. Okay, set A is 1 2 3, and we have to decide on this set R equals to empty set is reflexive or not. Recall definition of reflexive relation. In reflexive relation, there should be A comma A for all A belongs to capital A, and then there may be any extra element or may not be. So if we are calling a relation reflexive, there should be 1 comma 1, 2 comma 2 and 3 comma 3. But here we can see very clearly r equals to 5. That means r equals to empty set. We are not having any 1 1, 2 2 and 3 3 here. So empty set is not reflexive. Idea is clear? This is very important question. Empty set is reflexive or not? Empty set is not reflexive because this time we are forming relation on set A, and in set A we have entries as 1 comma 2 comma 3. So if relation on set A is reflexive, there should be 1 comma 1, 2 comma 2 and 3 comma 3 as a entry of a relation. But r equals to 5, we are not having 1 1 2 2 3 3 here, so this is not reflexive. Is it clear? Now come to next section. R equals to A cross A. What is this r equals to A cross A? This is universal relation. A cross A. All entries A cross A we are considering. Either we will write like 1 1 1 2 1 3 up to 3 3, or simply we will write A cross A. That means we are considering all these entries. So if we are writing r equals to A cross A, is it reflexive? Of course yes, because if we are considering entire entries, then definitely all A comma A is here, 1 1, 2 2, 3 3. So r equals to A cross A. There may be any extra element. It doesn't matter whether we are considering extra element as a 1 extra element or 2 extra element or 3 extra element or more than 3 extra element. Whatever. But there should be 1 1, 2 2 and 3 3. So in r equals to A cross A, we are considering entire entries. Definitely 1 1 2 2 3 3 is considered in entire entry. So this is a reflexive relation. Yes, it is reflexive. Yes, it is reflexive. Is it clear? Idea is clear. Now come to next section. R equals to 1 1 2 2 3 3. Is it reflexive? Yes, it is reflexive. Some students will say that no, it is not reflexive, it is identity relation. Oh, you can recall definition of identity and reflexive relation. In identity relation, there should be no any extra element. In reflexive relation, there may be or may not be any extra element. So this is the reflexive relation. Is it clear? Now come to fourth entry. R equals to 1 2 2 1 1 1 2 2. Is it reflexive? So recall definition of reflexive and check it. There should be all A comma A. There should be A comma A for all A belongs to capital A. We are having 1 1 2 2, but we are not having 3 comma 3 here. A is 1 2 3. There should be 1 1 2 2 and 3 3. We are not having 3 3 here. 1 1 is here, 2 2 is here. Well, but we are not having 3 comma 3. Okay, so it is not reflexive. It is not reflexive. Is it clear? Idea is clear? Okay, now come to fifth relation. 1 comma 2 2 comma 3 1 comma 3. Oh, this relation definitely it is not reflexive because we are not having 1 1 2 2 or 3 3 and we are having extra entries. No problem, we are having extra entries, but we are not having 1 1 2 2 3 3. So it is not reflexive. Is it clear? It is very easy to identify. Fine, na? See sixth one. R equals to 1 1 2 2 3 3 1 2. Is it a reflexive relation? Oh, of course yes, because we are having 1 1 2 2 3 3 here, and apart from this we are having some extra element. It is permissible in reflexive relation. Extra entry allowed in the definition of reflexive relation. So it is reflexive. Yes, it is reflexive. Yes, it is reflexive. Idea is clear? Fine. Thank you.